Imagine you could have a living, breathing copy of a real object, only it exists in the digital world. That's what a digital twin is. It's a virtual version of something real, like a machine, a building, or even an entire city. But it's not just a simple three-dimensional model you can spin around on your screen. A digital twin is alive with real-time data, constantly updated by what's happening in the real world. Think of it as a high-tech mirror. When something changes in the real object, the digital twin changes too. This happens because the digital twin is connected to the real thing by streams of data. These streams come from sensors and other devices that track what's going on. This connection means a digital twin is always up to date. It can show you the current state of a jet engine, a hospital patient, or a city's traffic lights. It's like having X-ray vision for the things we build and use every day. Digital twins help us understand, predict, and improve the world around us. They are powerful tools for engineers, doctors, city planners, and more. In the next sections, we'll see how they work and why they matter. Let's start with a simple example. Imagine your car has a digital twin. Sensors in your car send information like speed, temperature, and tire pressure to its digital twin in the cloud. If the car's engine starts to overheat, the digital twin spots the problem and warns you before anything breaks. This is not science fiction. Many modern cars already use this technology. Now picture a smart home. Each appliance, from your fridge to your washing machine, has its own digital twin. These twins keep track of how much energy each device uses and can suggest ways to save power. If something goes wrong, the digital twin can even tell you exactly what needs fixing. Hospitals use digital twins to model patients' hearts. Doctors can test different treatments on the digital heart before trying them on the real patient. This helps them choose the safest, most effective care. Even entire cities can have digital twins. City planners use them to track traffic, pollution, and energy use. By testing new ideas in the digital twin, they can make life better for everyone in the real city. So how does a digital twin gather all this information? It starts with sensors. These are tiny devices attached to machines, buildings, or even people. They measure things like temperature, movement, pressure, and more. The sensors send their data to the internet, where it joins a huge network called the Internet of Things, or IoT. Once the data reaches the cloud, a giant network of computers, it can be stored, analyzed, and shared. Artificial intelligence, or AI, steps in to make sense of all this information. AI can spot patterns, predict problems, and even suggest solutions, all much faster than a human could. The cloud is important because it lets people access the digital twin from anywhere. Engineers in London can check a factory in Singapore in real time. Doctors can monitor patients from their homes. The digital twin is always connected, always up to date. This mix of sensors, IoT, AI, and cloud computing turns a simple, three-dimensional model into a living, breathing digital twin. It's a team effort that brings the virtual and real worlds together. In engineering, digital twins are used to design and test everything from bridges to aeroplanes. Before building anything, engineers create a digital twin and run simulations. They can see how the real object would react to stress, weather, or wear and tear. This saves time and money and makes buildings safer. Manufacturers use digital twins to keep factories running smoothly. Each machine on the factory floor has a digital twin that tracks its health. If a part is wearing out, the digital twin warns the team before it breaks. This is called predictive maintenance, and it keeps production lines moving. In healthcare, digital twins are changing how doctors treat patients. For example, a digital twin of a patient's heart can help doctors try out different medicines or surgeries in a safe virtual space. This leads to better outcomes and fewer risks. Smart cities use digital twins to manage everything from traffic lights to water pipes. By testing changes in the digital twin first, city planners can avoid costly mistakes and keep cities running efficiently. One of the biggest benefits of digital twins is predictive maintenance. Instead of waiting for something to break, you can fix it before it causes trouble. This saves money, reduces downtime, and keeps people safe. Digital twins also help improve efficiency. By watching how machines or buildings work in real time, you can spot ways to use less energy or make things run faster. This is good for business and the environment. Testing new designs is another major advantage. You can try out different ideas in the digital world without risking damage to the real thing. This makes innovation faster and safer. Finally, digital twins make remote work possible. Experts can check on machines, patients, or entire cities from anywhere in the world. This is especially helpful in emergencies or when travel is difficult. The idea of digital twins started with NASA. In the 1960s and 70s, engineers built exact copies of spacecraft on Earth. These twins helped them solve problems when things went wrong in space. The term digital twin was first used in the early 2000s, but the concept goes back much further. Today, digital twins are used by some of the world's biggest companies. Siemens creates digital twins for trains, factories, and power plants. General Electric, or GE, uses them to monitor jet engines and wind turbines. These companies are leading the way, but many others are joining in. The use of digital twins is spreading fast. From car makers to hospitals, more and more industries are seeing the benefits. The technology is becoming cheaper and easier to use every year. As digital twins become more common, they are changing how we design, build, and care for the things we rely on every day. Looking ahead, digital twins will play a big role in the future of smart cities and virtual worlds. Imagine a city where every building, road, and bus has a digital twin. Planners could test new ideas instantly, making cities safer, greener, and more fun to live in. Digital twins will also connect with the Metaverse, a virtual world where people can work, play, and explore. In the Metaverse, you could walk through a digital twin of your own city, or even your own body. This could help with everything from urban planning to healthcare. As artificial intelligence gets smarter, digital twins will become even more powerful. They will not just show what is happening now, but also predict what will happen next. This will help us prevent problems, save resources, and create better designs. In the world of intelligent automation, digital twins are the key to making machines and cities work together smoothly. They are helping us build a smarter, safer, and more connected future.